All right. Today we are pulling back the curtain on something huge, the actual physical infrastructure of our digital world. We're going to talk about the people who design the very buildings that power the internet. Let's dive into what it really takes to design the engine of our digital lives.
I mean, seriously, have you ever stopped to think about it? We all talk about the cloud, but where is it? Well, it lives in these absolutely massive, high-tech buildings called data centers. But who actually dreams up the blueprints for these digital fortresses? It's not just, throwing up four walls and a roof. It's one of the most complex engineering challenges you can imagine.
Okay, to really wrap our heads around this, let's use an analogy. Think about a Formula One race car. On one side, you've got the expert mechanic. This is like your hands-on cabling or fiber tech. They are absolute masters of their craft, and they follow the blueprint to perfection. But on the other side, you've got the chief design engineer. In our world, that's the DCDC. This is the person who creates the blueprint for the entire system from the ground up.
So let's get to know this chief engineer a little better. What exactly are they designing, and who's making the rules for this high-stakes race?
First off, the data center itself. In our little story, this is the super high-tech garage. It's where thousands upon thousands of F1 cars, which are really the servers running everything from Netflix to your bank account, are built, stored, and kept in perfect shape. This is the literal, physical home of the cloud.
Now, you can't have a professional sport without a governing body, right? Well, that's where BICSI comes in. You can think of them as the Formula One Engineering Standards Committee. They're this global organization, and they literally write the rule books and the best practice manuals for how all this incredibly complex data infrastructure is supposed to be designed.
And that brings us right to the DCDC, the Data Center Design Consultant. This is our chief design engineer. This is the person who has to see the whole picture. They're answering the huge questions like, how much power are we going to need? How are we possibly going to keep thousands of servers from melting? How is data going to flow between all of them at the speed of light? See, they don't just tune the engine, they design the entire car. So what does this chief engineer need to have in their mental toolbox? Let's decode that blueprint and take a look at the core knowledge they absolutely have to master. It all starts with the big picture theory, which we can call the physics of racing. This is all about understanding the fundamental rules of the game. Things like where you should even build the data center, how to design for different levels of reliability, and maybe, most importantly, figuring out what the client actually needs before a single line is drawn. Next up, you've got the physical building itself. Think of it as the car's chassis and its life support systems. We're not just talking about the IT gear here, we're talking about the gigantic electrical and mechanical systems that keep all of that gear alive and running 24/7. And believe me, this gets incredibly specific. We're talking about designing fully redundant electrical systems with massive backup generators because even a millisecond of a power outage could be a total disaster. We're talking physical security with things like biometric scanners and man-traps to make sure only the right people get anywhere near that hardware. And of course, advanced fire suppression that can put out a fire without destroying millions of dollars of equipment with water. But the biggest challenge of them all is cooling. And let me be really clear about this. Servers generate an absolutely insane amount of heat. Managing that heat is one of the most critical jobs a data center designer has. It is a constant, relentless battle against physics. And to win that battle, you have to speak the language of thermodynamics. This little conversion factor right here, it's key. 1 kilowatt of IT power, that's about what a strong space heater uses, cranks out over 3,400 BTUs of heat every single hour. Now imagine thousands of those. The key takeaway is that every single watt of power that goes into the IT gear comes right back out as heat that you have to get rid of. So, how do they actually use that number? This is where the rubber meets the road. Let's say we have one server rack using 10 kilowatts. That's pumping out over 34,000 BTUs of heat. Well, using a standard formula, a designer can figure out they need to blast about 1,580 cubic feet of cold air through that rack every single minute just to keep it from frying itself. This is the kind of quick math they're doing all day long. So once the chassis and the life support are all sorted out, it's time to focus on the car's engine and its nervous system. This means designing the technology that lives inside the building. laying out all the server racks and designing that massive web of copper and fiber optic cables that acts as the data highway, connecting everything together. And finally, a brilliant design on paper is totally useless if it can't be built right and tested properly.
This last area covers overseeing the whole construction project and, most critically, performing that final shakedown test before the whole facility goes live.
And that phase is called commissioning. And let me tell you, it is absolutely non-negotiable. It's this final, super exhaustive set of tests where you push every single system to its absolute limit. You fake a power outage to make sure the generators kick on. You simulate a cooling failure. You are deliberately trying to break things to find every single weakness before the real race day.
So yeah, that sounds like a ton to master. And it is. This is a serious professional-level credential that demands real-world experience. So let's walk through the roadmap of how you get from being on the pit crew to becoming that lead designer. Okay, the journey can really be broken down into 5 key steps. It all starts with building a solid foundation and getting your hands dirty as part of the pit crew. From there, you'll earn a really important prerequisite certification. Then you'll transition into a design role. And finally, you'll be ready to go out and conquer that DCDC exam.
These first 2 steps, they are absolutely crucial. You can't design a race car if you've never held a wrench, right? The best designers, they all start as technicians. So, you go get foundational certs, then you get a job as a cabling installer or a data center tech. You'll spend a few years building what other people have designed, and you'll see firsthand what makes a good design work. And trust me, what makes a bad one a complete nightmare.
So after you get that field experience, the next major milestone is the RCDD. Think of it like a general architect's license for technology infrastructure. It proves you understand the design principles for cabling and networks in all kinds of buildings, not just data centers. This broad expertise is what makes you eligible to specialize later on, and frankly, it's a requirement for a lot of high-level design jobs.
Okay, with your field experience and your RCDD in hand, you can now move into a full-time design role. Your job literally shifts from pulling the cables to drawing the blueprints. This is where you gain those required 2 years of specific data center design experience that makes you eligible to finally go for the DCDC exam and earn your spot as a top-tier consultant.
So you've made the journey from mechanic to chief engineer. You're at the finish line. What does it actually mean to be ready to take on this level of responsibility? Well, what are the signals that you're ready? It's when you can confidently sketch out an entire power system, from the utility pole all the way to the server. It's when you can do that critical cooling math in your sleep. It's when you can pick the perfect fiber optic cable for the job, explain different levels of system reliability to a client, and ultimately create design documents that are just crystal clear and built for the future.
Look, this is so much more than a certification. It's a role that puts you at the absolute heart of the modern world. You're not just designing a building, you're designing the engine that powers our global economy, our communication, our entertainment, everything. So the only real question left is, are you ready?